Quantum theory, energy application part 2. So in this video, we'll talk about the next part. To what region of the electromagnetic spectrum does this photon belong to? So earlier in part 1, we found that energy is negative 4.09 times 10 to the negative 19 joules. And if we want to find the region of the electromagnetic spectrum, it has to be the wavelength. And the wavelength, how do we find that? Well, we have the energy, we need to find wavelength, and the only equation that I can think of is E equals to hc over lambda. And h and c, they're both constant. So h would be 6.626 times 10 to the negative 34 joules seconds. And c is the speed of light, 3.00 times 10 to the 8. Sometimes they have 2.99. I'll just put 3.00, depending on which data booklet you're using. Anyways, so now we have 3 known variables, and we're just finding one unknown. So that's good. So negative 4.09 times 10 to the negative 19 joules. Always keep all the units, because if you have all the units, you can use unit analysis to make sure that you're doing this right. So you times it by 3 times 10 to the 8 meters per second. Everything over wavelength. So let's use unit analysis. Seconds and seconds, they're gone. So if they're gone, to save some room, you can just flip this. I'm not going to rewrite it. Because imagine if you flip these two, the joules and joules, they can cancel out. Okay? Or you know what? You could have just go like this. Just do the math earlier. So lambda is hc over E. All right, anyways, lambda right now, if you put everything into your calculator, you should get 4.86 times 10 to the negative 7 meters, because I have meters here. Okay? So now you can leave it as meters, or you can change it back into nanometers. So we can use unit analysis again. Times 1 nanometer is 10 to the negative 9 meters. So this is gone and gone. So ultimately, if you put that into your calculator, you should get 486 nanometers. And that is in the visible region. And we're done.